Hello guys, so today we'll be going through problem 16 through 20 of the 2024 AMC10B. Number 16. Jerry likes to play with numbers. One day, he wrote all the integers from 1 to 2024 on the whiteboard. Then, he repeatedly chose 4 numbers on the whiteboard, erased them, and replaced them by either their sum or their product. After repeatedly performing this operation, Jerry noticed that all the remaining numbers on the whiteboard were odd. What is the maximum possible number of integers on the whiteboard at the time? So, we have sum. Well, the only two ways to get a sum of an odd integer from 4 numbers is O plus O plus O plus E. This gives us an odd number. Or E plus E plus E plus O. And well, where E represents an even number and O represents an odd number. And for product, O times O times O times O gives us O. That's the only possible case. Okay, so we want only odd numbers, and we gotta maximize this. So from 1 to 2024, there are 112 odd numbers and 112 even numbers. We want to get rid of all these numbers. How do we do that? Well, the most efficient way is to use formula 2. And what this means is that we input 1011 E's, and we input 337 odds to make 337 pairs of E plus E plus E plus O. So this gives us 337 odd numbers. And then, well, there's one even number left because we only used 1,100. 1,011 even numbers. So now we have to use the next formula. And this is not as cost efficient. We have to use one even number and 3 odd numbers. And this gives us one pair of O plus O plus O plus E. And this gives us one odd number. So we have 1012. We have to subtract 337 because we used this into the sum. We get back 337. We use 3. We get back 1. So using this gets 0. This gets -2. So 1012 gives us 1010. Because, well, 1012 minus 2 is 1010. Problem 17. In a race among 5 snails, there's at most one tie. The tie can involve any number of snails. For example, the result of the race might be that Dazzler is first, and Abby, Cyrus, and Elroy are tied for second, and Bruno is fifth. How many different results of the race are possible? Okay, so we do case 1. Case 1, no ties. If there's no ties, then there's 5 factorial, because there's 5 people to choose for every spot. For first place, there's 5 choices. For second place, there's 4 people to choose from, ... Now, case 2, one tie. And, well, there's many subcases to this. Subcase 1. So a tie is between 2 people. And what this means is that, for example, A and B are tied for first, and then D, C, E are next. So we have to choose 5 choose 2 for the 2 people that are going to tie. There's 3 factorial for the other people to arrange. And let's say this is tie, D, C, E. There's 4 places for the tie to be. Times 4. So this gives us 240. Subcase 2. The tie is between 3 people. So like a 3-way tie. So what this gives us is let's say A, B, C tie. This gives us 5 choose 3. D and E are left. There's 2 factorial ways to arrange them. And tie, D, E, there's 3 places for the tie to go. So this is 60. Subcase 3, the tie is between 4 people. So we're nearing the end now. 5 choose 4 to choose the 4 people that are going to tie. And then, well, the last guy is 1, and the tie can go two places. I can go here or here. So this gives us 10. And finally, this is our last case. Ooh, that's the next problem. So subcase 4. All of them tie. If all of them tie, that's just 5 choose 5. Which is 1. So we get 120. This is 120. Plus 240 from subcase 1. Plus 60 from subcase 2. Plus 10 from subcase 3. And plus 1 from subcase 4. 300, 130, 1 gets us 431 as our final answer. 18. How many different remainders can result when the 100th power of an integer is divided by 125? So we have Euler's totient theorem, where it states that any integer a to the totient of n is equal to 1 mod. And this is only if a and n are relatively prime. So what is the totient of n? The totient of n is 125 times 1 minus 1/5, because 125 is 5 cubed. And well, the only prime factor of 125 is 5. So this gets us 100 as totient n. And conveniently, that's what the question's asking for. So a to the 100 is equal to 1 mod 125. But this have to be relatively prime. So if a is not divisible by 5. Now what if a is divisible by 5? If a is divisible by 5,
Thank you for watching, and if you liked the video, like I said,
then 5 to the 100 is obviously 0 mod 125. So here we have our answer, 2, because it's either 0 or 1. Problem 19. In the following table, each question mark is to be replaced by possible or not possible to indicate whether a non-vertical line with a given slope can contain the given number of lattice points. Let's start off with 0 slope. So let's do, this is y equals 1. So first of all, our line could be y equals 1. And that means that 0, 1, 1, 1, 2, 1, it intersects at more than 2. Or we can have something like y is equal to 0.5. And this will have 0 possible ones, because it's never going to hit a lattice point. Now for non-zero rational slope. So for non-zero rational slope, we can have something like y is equal to 1/3 x plus 1/6. And obviously, this is never going to hit a lattice point because there's a fraction here. So 0 is this case. Or another side of the coin is y is equal to x. And well, the slope is 1, which is rational, and this hits every point. And lastly, the irrational slopes. Looks very similar to the rational slopes, but there's one key difference. So let's say y is equal to root 2x. This is exactly 1 point, because the only point that works here is 0, 0. And lastly, just like this, we have y is equal to root 2x plus 1/6. Or we can have root 3. Either way, this will be 0 points. It's never going to hit a lattice point. So we have 1, 2, 3, 4, 5, 6 possible cases. Number 20. 3 different pairs of shoes are placed in a row such that no left shoe is next to a right shoe from a different pair. In how many ways can these 6 shoes be lined up? So now we just do some long case. So if we start with left pair and we start with a right pair. So if we start with left 1, then we can go to left 1, right 1, or left 1, right, left 2. There's only 2 cases, left 1, right 1, left 1, right 2. And obviously we can't have left 2 next to that or else it'll be different. And we just continue listing cases, not too hard. From here on we can have L1, L2, L1, R1, R2, and L2. or we can continue on with the R's. From here we have to do R3, and from here we can do not R1. It actually can't be R1. If it's R1, wait, no, it can't be R1, sorry. So from here, our case is determined. From here, and from here. Now for R1. So for R1, we start with R1 L1 or R1 R2. And this leads to, and this leads to, so we just continue doing casework. It's nothing special. Doing this. From here. That's our final case for this one. So here we have all our cases. So what we do is start counting the possibilities. So for this case, the possibilities are, well, we can choose any number for the first number. Doesn't have to be L1. R1 depends on L1. R2 and R2 and R3 can be interchanged because we can have R2 first or R3 first. So we multiply by 2, 6. The next one. Obviously, we have 3 first. We can pick any number first. And same with this. We can do R3 and then R2. So here, I'll show you. So we can do R2, R3, or R3, R2. So that's also 2 cases. Now, moving on to this one. We can obviously 3 times. And now we can do L2, L3, or L3, L2. We can do them interchangeably. And we have this case now, which we have 3 cases for the first one. And the key difference here is that we can choose the L2. So we can do L2 or L3. And now there's 2 choices because for here we can do R3, L2, L3. Correction is this can be multiplied by another 2. And we see this because here the last 2 can be interchanged. The last 2 can be R1, R2, or R2, R1. So that's 12. Moving on, with this case, we get 3 to choose the R. L1 depends on it. And then L2, R2, and L3, R3 can be interchanged. For this one, same thing as above. You can interchange them. For this one, 3 cases for the first one, and then 2 cases for the next one. Lastly, this one, this is a special case. 3 choices for this first one, then there's 2 choices, and then these 2 can be interchanged. So we get 2 times 12 plus 1, 2, 3, 4, 5, 6. 6 times 6. So this gets us 24 plus 36 to get us 60 as our final answer. Thank you for watching.